Okay, I'm making this video today to show you how to slice STL files for 3D printing. When you're going to 3D print a model, you're going to need to convert an STL model like this one that I have on my desktop right here to G code for your printer. And to do that, you're going to need some slicing software. So what you should do is jump on the internet and download yourself Cura. That's what I'm going to be teaching today. It's the one that I'm the most familiar with. It's free and it covers a very wide range of printers. When you click on Ultimaker Cura, you can download it for free. And then after, you're going to install it to your computer. I'm not going to show you that process as I think you can probably figure that out for yourself. After you're done, you're going to just simply click on the Cura link and load Cura. You can see that my version is 5.3.1. I haven't been having any issues with it, so I would say it's probably a good version. When you open Cura, this is what it's going to look like. And you're going to want to get started by adding a printer. Don't make the mistake of just using it. You do have to add your particular printer, whether you have yourself an Anycubic Viper or maybe a Creality Ender 3. So I'm going to add a non-Ultimaker printer. Of course, if you have an Ultimaker printer, you're going to click there. And from these lists here, if I have a network printer and it's over my network, it should show up here. And then I can click that network printer. I don't print over a network. I always print with a USB stick. I feel like it's a little bit more safer to do in power outages and losing connections and all that sort of stuff. I just think that the micro USB that you can put in the printer is a better way to go. So I'm going to add a non-network printer. And we're going to go back with the Creality Ender 3 just because it's one of the most common ones in the world. Um, from this list here, I can search down for the Ender 3, and mine happens to be a version 2 Neo. So I see the Neo is not an option here. So I'm going to go with the closest thing and then hit add. What's going to tell me if it's the right printer is usually if it has the same print bed size, which my Ender 3 actually does have a 235 millimeter X and Y axis bed. And it'll print a model 250 millimeters tall. So this is my printer. From here, not just when you're adding it, you can always manage your printer. You can come in and customize start and end G code. What start and end G code are is Cura has a custom G code for the Creality Ender 3. So when it starts, it's going to reset the extruder and it's going to home all the axes and it's going to maybe prime the nozzle on the print bed before printing. And that's a very, very common start code. If you're wanting anything different from that, you're going to maybe have to find um, a resource that has some custom G code, or obviously, if you know how to write code, you can do it yourself. The end code, very, very similar. I like to see that it retracts a bit at the end so my nozzle doesn't get stuck to the extruder when it cools down, and it'll probably retract and raise up and home itself. When you click on extruder here, you're just looking to see that 1.75 millimeter filament is chosen if that's the size of filament you're using. If you're using like a 2.8 or something like that, then you'll click that, but I'm just going to move on. Now that I have the right printer, I'm going to just check to see if the nozzle size is correct. Just about every printer that comes starts with a 0.4 millimeter nozzle. If you've made changes to your printer or your printer has something of another size, you can make that change here. Like a very common one is 0.6, just to print models a little faster and maybe bigger, stronger models, okay? Of course, you can go down the other way too. I'm going to just leave that alone. And PLA is pretty common for everybody that's starting out. You probably got some PLA with your printer for free, maybe when you bought it, and then you probably bought a couple of rolls just to try out. Okay, now that we've selected our printer, we're going to look at the options that are over here on the right. This is a very basic level of options, and if you get better at the program, you can then start messing around with your custom um, options. And this is still just a very small list what Cura has available. If you want to add a setting, you can configure the setting visibility up here. And then you can see anything that's on this screen here. And as you can see, there is a lot. All of those to choose from. So the ones that I have checked are ones that I wanted to see, okay? And some of these other ones I just don't bother with, okay? So it's just going to depend on what you're comfortable with. We're going to slice today with the recommended settings here. And we're going to let Cura make the choices for pretty much everything else. Okay, first thing that I'm going to do is I'm going to open an STL file. Maybe you've downloaded this off of Thingiverse, or you have a subscription maybe to another site that has STLs or whatever. So I'm going to bring in my 3/4 inch combination wrench that I made myself in Fusion 360. That's a totally different beast there. You're going to notice right away that this model is way off the build plate, and it's just like hash marked, and it looks weird, right? And that's because it doesn't fit. So here's the move button. If I move and drag this into place, you can see that the wrench is just too big for the build plate. Right below the move button is the scale button. And if uniform scaling is in, I could change this number to, let's say, 50%. And then you can see that my 3/4 inch wrench fits really well, but that's not the size of it. Also, what's good to note is all these sizes on the side are actually the measurements of the wrench. It's going to be 140 millimeters on its y-axis and 20 wide on its x-axis. Anyways, I want 100% wrench, so I'm going to have to find another way to fit this thing on here. So what I can do is rotate it, okay? I could rotate the wrench so it stood up. Oh, maybe I can't because it's still too tall for my printer. Okay, so that's not an option. Uh-oh, what did I do now? We're going to, shouldn't have messed with it. Okay, what we're going to do is we're going to rotate the wrench sideways so it fits on the build plate. We're going to select all models and get this thing to fit on here. You can see that I'm really struggling here. So what I'm going to do is I'm going to Control Z back to this point here, because that's when I really messed everything up. And this is actually great for you to see, probably. If it isn't, I'm sure I'll hear about that in the comments, right? What are you doing? You don't even know. Okay. So this wrench is really big for this build plate. But there we go. We got it to fit with a little bit of fidgeting and a little bit of playing here. And this build plate is really maxed out with this size of the wrench that I'm going to do here today. But after it's yellow like this, or a solid color, then this thing is ready to print. As I get spinning around, you'll see that it's marked Ender on the bed, and looking at the words this way, Ender, that is going to be the way I look at my 3D printer. Okay, now that I've got my wrench highlighted properly and it's actually on my print bed, then I can go ahead and change these settings to print this the best way possible. We're going to start this with resolution. And right now it's in the standard setting of 0.2 millimeters. What that means is that when it prints, it's going to outline this wrench on its first layer, go all the way around, and then it's going to infill the wrench. It might do them sideways, it might do them lengthwise, the first one. You don't really have to worry about that. But when it does its next layer and it goes up a layer to print on top, it's going to move up exactly 0.2 millimeters. So that's important. That is standard quality for a Creality Ender 3 and for most printers. It'll do this model very good, okay? I don't think I need to worry about doing less than that, but the resolution, the way you can change it is to change it to dynamic or super. When you change it to super quality, the nozzle is only going to move up 0.12 millimeters each time. That's going to make a really big difference on how pixelated this wrench is or how smooth the model is. It's also going to take about twice as long to print it. So if you have a model that has really fine details, super quality might be for you. This, this wrench definitely does not have a level of detail like that. So I could go to standard or even low. It might even look just as good on low. But what I'm going to do is select standard quality. Then you have a setting that says strength. And in the strength menu, you have infill, density, pattern, and the shell thickness. So I'll just explain those very quickly. Infill density will be um, inside the model. This wrench will not be printed solid plastic. It'll have space in between the layers X and Y direction, almost like little squares inside if you choose the pattern cubic. If you were to choose triangles, it would have little hollow triangles inside. So infill is used to make it look attractive, to use less plastic, and so it's not just a solid plastic piece. I don't think I ever print anything as a solid piece. But by increasing the infill, let's say to 40%, you're going to make a model that is about twice as strong as that 20%. Maybe not twice as strong, but it'll be much more rigid. I rarely ever do more than 40. 60 is very, very high, and I don't think I've ever printed anything at 100% infill, as it actually isn't going to necessarily make it stronger. Those those gaps inside, they all become part of the integral strength of the model. So 40, 60% is very strong. 20% is very, very standard. So you can choose that, and you can play with some different designs here, but grid or cubic are very, very common. Now we're going to talk about the shell thickness. The shell thickness is on the outside of the infill will be the walls. Right now, the walls or the shell thickness is set to 0.8 millimeters. The significance of the number 0.8 will go back to my nozzle size. My nozzle is supposed to be laying down 0.4 millimeter width lines of PLA. So a shell thickness of 0.8 means that I'll have two lines or two layers, if you will, of solid filament on the outside of the infill pattern. If I want to change that to 3 lines, then I would look at my factor of 0.4, times it by 3, and I would get 1.2. And I could change it to 1.2. That will be another way to make my model stronger. If I was going to do 4, then it would be 1.6. This wrench is not made for turning fasteners. It's more of a backdrop for wrenches in a toolbox. So 0.8 will be just fine. Okay. As you see, when I can hover over things, Cura is going to tell me what some of these settings are. So that'll always be very helpful. If I turn supports on, you're going to see that what supports are used for are if your model needs a bridge to maybe put something out in the middle of nowhere. Let's say this wrench had an arm that came up and hang down a light off of the print bed. Okay? The way that printer would try to print that, it would print the wrench and it prints the arm up, but then it has to come over and start the light that it has on there, and it can't. It'll just drop the filament down on the print bed. So what build structure is, it would build a bridge up with the model to where the light would start, and then it would print the light. So if you need support for your model, you could choose a normal or tree. Now tree is just going to look like tree roots. Some people really, really like it, but I would just keep it at normal and then adjust that as you get more comfortable with this. You can make supports everywhere, or you can have the supports where they're only touching the build plate. So you can make those decisions when you have a more complex model in. A lot of models that you find on Thingiverse or free STL ones actually don't need supports. So you can just turn them off. Adhesion are going to be things that help you stick to your printing surface. Okay. A lot of the newer printers nowadays, they stick very well. I hear a lot of people using glue sticks and lots of other things on the printer. You're going to have to figure out what works best for yours, but I find that a finely tuned, well leveled printer with good Z offset really doesn't need um, adhesion turned on very often. So I'm going to turn it off. Now, what a raft is it makes like a platform for the wrench to be on. So the platform is printed down first and then the wrench is put on top. And then what a brim is pretty much a layer of plastic around the outside of this wrench that is going to maybe make it bigger. And that brim is going to help it stick to the print bed a little bit better. Anyways, I don't think that's necessary today, so I'm going to shut it off. After I have these selections made, I can go ahead and slice my file. When I slice my file, it's going to tell me how long it's going to take to print, how much filament it's going to use, and it's going to allow me to preview it or save it to disk. You can also preview it up here on the menu, and that's what I normally do. Okay, and then you can drag this indicator up and down, which is the number of layers it's going to take to print. So this wrench of mine isn't very tall. It's only going to be 11 layers of filament. And if you actually want to see how it's going to print any of the layers, or you want to view the infill or anything like that, you can set it to, let's say, layer 5 and hit the play button. And it'll show you actually how the 3D printer is going to print your model. I recommend always previewing all your models just to make sure that on the preview page it looks like it's correct. And if you have selected supports or whatever, that the supports are in the right spots and everything's tickety-boo. If it's not, then you're going to want to make some changes to your settings. So always, it's a very good practice to always preview. Okay. All right. After I'm happy with what I've got, I can then plug in my USB stick with my micro USB in it or whatever disk fits your printer. And you can see here it's going to give me the option to save it to my removable drive. I'm going to click on that. It's going to tell you the file name that it's going to use. And if you're not happy with that, you can always go in here and change your file name by going to this PC, opening up the drive, and then finding that file and making a change to it. Oops. So we'll just rename it Wrenchy Poo. And that's how I know what I'm going to be printing. I can go ahead and eject. And there you go. That file is ready to be plugged into the 3D printer, and simply I'll hit my print button. After my print button is done, my printer is going to start warming up. And what it's going to do is warm up to the initial printing temperature of 200 degrees Celsius, because that was the temperature that Cura picked for PLA up here. Okay, it's going to warm the build plate up to 50, and then it's going to initiate those start G codes that you saw before, and then it's going to lay down layer 1 by doing that, printing the brim and then moving on to the wrench. If I speed it up here, that's literally exactly what your printer is going to do. If you have any problems, it'll usually be laying down the first couple layers, Z offsets, and build adhesions. That's just for another video, and that's just for another time. But that should help you if you are new to the 3D printing world and confused by what slicers were and maybe which one to use and how to use them. So yeah, happy printing.